Hello, my name is Gopinath Taget and I will be presenting the second part of the introduction to Revit programming. I have been a part of the Autodesk Developer Network since 2004 and have supported APIs on multiple products including AutoCAD, Map3D and Revit. Today, we will learn about the Revit API through creating a room numbering add-in. The way this add-in will work is, it will ask the user to keep picking rooms and it will set those room numbers starting with 1. It also needs to make sure that 2 rooms do not have the same number as a result of this renumbering because Revit would not like that. While implementing the add-in, we'll see how to find out what exact room parameter needs to be changed, how to pick objects in the user interface, and how to find out using filtering if a room is already using the number we are trying to set to another room. But before we start programming, I'll show you quickly how the add-in will work once it is finished. This might make it easier for you to follow what I'm doing while I'm implementing the add-in. As you can see, in this drawing, the room numbers are not in order. So I will go and start my command, which is called command room renumbering, and I will start picking rooms. I want this room to have the room number 1 and this one to have 2 and so on. So as you can see, if a room already has a number that I want to assign to another room, then the second room and the first room swap numbers. For instance, I want this room to have the number 3, but this room already has that number. So when I pick this room to have the number 3, this room swaps its original number with this room, which now has the number 5. And as you can see, all the rooms are in order now. You have already learned in the Introduction to Revit Programming Part 1 how to create a Revit add-in. I used this approach and already created a skeletal add-in that I will use in the rest of this presentation. Here is the simple skeletal application that we created. The name of the application is Room Renumbering, and we have added the Revit assemblies Revit API and Revit API UI to the references, and it has the skeleton for one single class called commands, which implements the iExternal command interface, and this interface includes the method execute that has been implemented here. So we will be adding code inside the execute command to implement the rest of the room numbering sample. So we have our add-ins framework now, and we need to start implementing our add-ins functionality. First of all, we need to let the user pick the rooms he wants to renumber. For this, the API provides the necessary functions under the UI document.selection. Each of these functions have quite a few overloads, so you can use them with different parameters. In our case, we just want to ask the user to keep selecting rooms one by one. Therefore, we'll use the pick object method. The first step is to get access to the UI document object that we can get from the command data parameter. The next step is to create a loop within which we can keep requesting the user for selecting a room. So let's create the loop. Within this loop, we can continue to ask the developers to pick an object, pick a room. So for this, we can use the UI document. pick object. There are several overloads for this method, and we will be using a specific overload. The first parameter is of the object type, so we want to pick an object of type element. And let us specify a message that says pick a room. The pick object method returns a reference object. The reference object is a stable reference to a geometric object in a Revit model, which is used when creating elements like the dimension. You will observe here that there is no real way to cancel out of this loop or exit out of this loop. So in order to be able to exit out of this loop, we should be able to handle the escape key or the cancel operation by a user. The escape key or the cancel operation throws an exception called operation cancel exception. So we need to be able to handle that exception. So let's create a try catch block. And the type of exception is the autodesk.revit.exceptions.operation cancelled exception. We don't really have to do anything in this, but just catch that exception so that we can exit out of this loop. And let's just copy this loop into the try catch block, and there we are done. This way we can easily exit out of the loop by just hitting the escape key. Now going back to the pick object method, you will see that the second parameter is not specified here. We are using a pick object overload that uses 3 parameters. If you look at the help for this, you will see that the second parameter is of type iSelectionFilter. An object of type iSelectionFilter will allow us to specify that only an object of type room needs to be selected. So we need to implement the interface iSelectionFilter. We'll go ahead and do that now. So we declare a class mySelection, which mySelectionFilter, which implements an interface called iSelectionFilter. Let's just go ahead and implement that interface. The interface needs 2 methods that needs to be implemented. One is the allow element and the other one is the allow reference. In our case, the allow element method is important, as this is the method that gets called by the pick object method when we specify that we want to pick an object of type element. So we want this method to return true if a room is picked. So the way we do that is we say return element is room. So the is operator checks if the element is of type room, and if it is, then it returns true. And that is the way the element is picked in our pick object method. Now the allow reference method is called when we specify other types of object types to be picked. In this case, you can see that the other options like face and point on element, when these 2 options are selected in the pick object method, then the allow reference method is called by the Revit system, and you can then choose to return true or false to allow the pickObject method to pick that specific element. In our case it is not relevant, so we can either return true or false. So we can just go ahead and return true. Now that the iSelection filter interface has been implemented, let us go ahead and use it in our pickObject method. And then we are done. Now that we have the reference object, we can get the room object from the reference using this approach. UI doc dot document dot get element and pass in the element ID that is referenced by the reference object. And cast this to a room. Now that we have the room, we need to change its room number. Now, how do we determine which parameter needs to be changed in order to change the room number? For this, we can use the Revit lookup tool. The Revit lookup tool used to be a part of the Revit SDK up until the 2014 version, but starting with Revit 2015, the Revit lookup tool is available separately on the GitHub repository. At the end of this presentation, I will provide links that will allow you to access this GitHub repository. You will also find the link to the GitHub repository at the bottom of this slide. So let us go to the Revit instance and see how we can check the parameter. In part 1 of this DevTV series, you should have seen how to use the Revit lookup tool and what this tool does. In this case, I would like to determine the parameter to change the room number of a room. So I have selected a room, and then I go to the Add-ins tab and use the Revit lookup panel to determine what the parameter is. For this, I select the Snoop current selection option. It gives me a list of properties, and one of the properties is parameters, which provides another list of properties. And here you can see one of the parameter is number, which is defined by a built-in parameter called room number. This is what we want, and this is what we will be using later in this code. But again, if you go back to the list of parameters of the room object, you will see that a very simple method of obtaining the room number is to use the number parameter, as this parameter or this property is directly available on the room object. So it is really easy for us to change the room number now. Now that we know which property to change in order to change the room number, we can code for it. The first step is to create a variable that will hold the latest room number. It's of type integer. Let's call it room num and initialize it to 1 because that would be the first room number. And we can use that variable to change the room number. And say room num and then after this we can just increment the room num so that it can be used for the next room. We would need to make sure that no other room is using the numbers we are trying to assign to the selected room. So we need to search for existing rooms in the database. Whenever you want to get access to any of the database objects, you have to create a filtered element collector object and specify the document and perhaps the view that you're searching in. There are loads of Revit filtering classes that help you get back the exact object you are looking for. You should narrow down the set of objects as far as possible using the Revit API, and only then use the generic API including link queries to filter down the selection to the specific element you want. This is because this way your code will be much faster. In our case, we can get back the element we need only using Revit API. So first, we need to create a filtered element collector. We can also specify the type of objects we are looking for using methods like wayPassers and offClass, which dramatically reduce the element set and so make further filtering quicker. For rooms, we can use wayPassers with the room filter object. Then we can narrow down the collection to the exact room we are looking for using the wayPassers again, which requires a filter that is based on a specific rule. A rule requires three parameters: a provider that returns the parameters value, an evaluator that tells Revit how we are comparing the values, and the value itself, in our case a string that we are comparing to. In this case, we are checking if the room number parameter of a room equals to the string we pass in. So like I mentioned, the first step is to create a filtered element collector. We can now use this collector to filter for rooms using wayPassers and using the room filter object. The next step is to filter according to a specific custom filter. This custom filter will filter rooms according to a specific room number. So let's call that object just a filter. So we would be using it something like collector wayPassers. The filter we want will be of type element parameter filter. So let's create an object of that type. And this parameter filter would be according to a specific rule. The rule itself will be of type filter string rule because we are trying to find a room with a specific room number which is of type string. So let's create that. Now this one, as I mentioned, takes a provider and evaluator, the value itself, and the fourth parameter which says if the comparison is going to be case sensitive. In our case it doesn't have to be, so we can just return false. So provider and we would like to compare it with the room number that we want to assign to a selected room. So that would be the room num integer. We convert it to string because this is a string comparison, and we say it's not case sensitive, so that is false. And now we need to specify the provider and the evaluator. The provider would be a parameter value provider because we are trying to find a room with a specific parameter, room number parameter value. And the parameter value provider takes a parameter of type element ID. So let's create a new element ID, and in this we can pass in the ID of the built-in parameter. So in this case it's built-in parameter room number. The evaluator is a filter string equals evaluator because we are trying to compare two strings and see if their values are the same. So with this we have created the second custom filter which will be used to find rooms with a specific room number in the document. I will now go ahead and use the collector object to obtain the room with a specific room number. For this, all I have to do is say collector dot two elements, because all the filters exist now, so all I have to do is two elements, which returns an list of elements. Let me store this in a variable. The list will be of type element, so let's just call it element, and the name of the variable is rooms because it is going to be a list of rooms. We do know that it's just going to be one room, but it's still going to be a list. Now if a room is available with a specific room number, the count of the list of elements would be greater than 0. So we can check for that. We can say if the rooms dot count is greater than 0, that means a room with a specific number has been found. In that case, we want to swap out its number with the room number of the selected room. So we say get me the room. For that we use index rooms 0, that is the first element, and because this is an element we need to cast it to a room object, and we can then obtain its dot number property and then assign the selected room's number to it. Now the swapping is complete. The one final step you need to perform in order to complete this application is to regenerate the document. You have to regenerate the document every time you swap out the numbers so that the swapped values are visible in the drawing. So in order to do that, you can say UI doc dot document dot regenerate. This will make sure that with every swap the document is regenerated and the swap numbers are visible in the drawing. Let us now go ahead and test our code. So let us start Revit in a debug process. Launching Autodesk Revit. I will now open a project with rooms in a random order. Let me zoom in so that the room numbers are clearly visible. I'll go to the Add-ins tab, go to the list of external tools where my command exists. My command is called command room renumbering. I launch it and I start selecting rooms. As you can see, the first room has been renumbered as 1, 2, 3, 4, 5 and 6 and 7. So the application works as we desired it to. You could also use the Addin Manager that comes with Revit to test your add-in. As you can see, it can help you create an add-in manifest file. It enables you to run an external command without an add-in manifest, and it also lets you load and unload your add-in within the Revit session. Let's now see how it works. When debugging a Revit add-in, you cannot do an edit and continue. In other words, you cannot modify an add-in's code while it is loaded in Revit. Also, you cannot stop your project, modify it, compile it, and reload it into the same Revit session through the debugger. If you think that you would really need this feature, then you could have a look at the Addin Manager tool, which you can use to register your add-in and also load and unload it in the same Revit session. Let me show you how this works. Once the Addin Manager is installed, you will find it under the External Tools panel in the Add-ins tab. You will find several options for the Addin Manager. You have the manual mode, the read-only mode, and the automatic mode. The mode that you use will depend upon the transaction mode of your application. In your code, if you're using the automatic transaction mode, then you will have to use the automatic mode in the Addin Manager. Similarly, if you're using manual or read-only, then you will have to use the appropriate manual or read-only mode in the Addin Manager. In our case, we are using the automatic mode, so I will use the automatic mode to load my application. I can click the load button, browse to the location of my DLL, load it, and it will list the commands under this application, and I can now choose to run this command for my application, and I can use it just like I have been using it in the normal mode. So I can renumber this room to 1, this one to 2 and 3 and 4 and so on. Now, if I want to make changes to my code without shutting down Revit, I can do that. I can go to my code and I would like to, for instance, change the message that I gave. I can say pick a room 2. I can save it. I can build the solution. I can go back to Revit. Go to the Add-ins tab, External Tools, Addin Manager, and I can run the command again, and at the bottom you will see that the message has changed, pick a room 2. If I want to debug my add-in in the same Revit session, I could go back to Visual Studio, go to the debug menu, attach to process, use the attach to mode of managed, as this managed mode will allow us to attach and detach from the Revit session as we want. If you use any other mode, you will have to shut down Revit and restart it before you can debug through it. So we strongly suggest that you use the managed code mode. You use this mode, browse down to Revit and say attach. Now your code is attached to the Revit session through the debugger. You can specify a breakpoint anywhere you want. Go back to Revit and run your application, and you will see that the breakpoint is hit. You can debug through it just like you would debug in any other application. Once you're done with your debugging, you could go back to your Visual Studio instance and then go back to the debug menu and say detach all, and your Revit session is still running while you can go back and start making changes to your application. So in this way, you can make modifications to your application, debug through it, and run everything in the same Revit session without shutting down Revit. Also, one important point to note is that because we want to modify our add-in while Revit is running, we need to make sure that it is not registered. That is, Revit will not load it in the normal way, because that will prevent Visual Studio from overwriting your module with the latest build. For instance, I had to comment out relevant portions of my add-in manifest file so that my application will not load the normal way. If you want to just test certain functions and not your whole application, then the easiest way is to use the Revit macro environment, which is a part of Revit. Finally, here is the list of resources outside the Revit SDK that you would be interested in. Jeremy Tamek has a really good blog that is updated with new and interesting articles almost every day, and also contains further samples for all the API functions we use today. We also have another popular developer blog for AEC products, to which I and several of my Addin colleagues contribute. Next, we have the Developer Center, where you will find a good overview of all API technologies that we support, and also, if you're interested, you'll find some free .NET training material for you to work through. Then, of course, we have the various discussion groups for you to check. And if you're interested in joining our Addin program, then please take a look at autodesk.com/join Addin, where you can find out about all the benefits that Addin membership has to offer. Continuing with our list of resources, here are two GitHub repositories that you will be interested in. The Addin DevTech repository contains the latest version of the Revit developer training labs, among other things, while Jeremy Tamek's repository contains the latest version of the Revit lookup tool along with other samples. I hope you found this presentation useful. Have a nice day.